Uh, Thanks, Marty. I'm happy to be back here today. We're going to focus today on program planning and evaluation for utility customer programs. We'll talk about program design, evaluation, benefit cost analysis, and an example application to make it real, looking at managed charging for electric vehicles, just as an illustrative example. I'll post the link to all of the slides for this week in the chat shortly, and our recording will be posted there soon, probably next week. I just want to introduce our presenter today, Steve Schiller. He is an affiliate with the Lab's Energy Markets and Policy Department. He's got more than 30 years of experience in the industry with a focus on distributed energy resources, from combined heat and power to energy efficiency and demand flexibility. He's overseen the development and administration of programs in over a dozen states and other countries, both on the utility side as well as the government side, so pretty well representing a lot of the organizations here today. He's highly experienced and he's internationally recognized in this field of evaluation, measurement, and verification and benefit cost analysis. He's written many of the guidelines and protocols that industry uses, including the National Standard Practice Manual, International M&V Program Guide, some of the U.S. Department of Energy works in the past, FEMP, ASHRAE, EPA, DOE, you name it. So we're really happy to have him today. I hope you do feel free to ask a question. So if you want to just raise your hand using the raise hand function, or just if you're really excited, you want to unmute yourself and chime in, we think that's okay. Also, just feel to post comments or ask questions in the chat. As Marty said, if you just want to send the question to me, that's fine. I'll be happy to ask it for you, or you can put it in the chat so everybody can see your question. All right, let's hear from Steve.
Hey, thanks, Lisa. Thank you, Lisa. Thank you, Marty, for the introduction, and happy to be here. I'm looking forward to the opportunity to present to you all today and hopefully provide some information that's helpful in your work and in careers as you move forward. As Lisa mentioned, we're going to focus on utility programs and actually with a focus on distributed energy resources, which I know is another topic that you have covered tomorrow as well. And we're going to be going first over a section on program planning, and then evaluating programs, and then benefit cost analysis for programs. And as Lisa mentioned, then do kind of a quick example. Excuse me. And we're going to do this all in 2 hours with maybe a little break in there. So let me push the right buttons here and get us going on to the slide on program design. So hopefully folks will be able to see this. And let's start at the beginning. I think that would be a really good idea. And that means I'm just going to do this. Sorry about that. So here, I hope you enjoyed all those slides going backwards. And now let's see if we can do them forward. So this one's going to be about program design for DERs, programs. And let's start off with just a quick definition, which is probably most of you are familiar with, but basically distributed energy resources, or DERs, they're assets that are close to the energy consumer, the utility customer's site, and they either support the facilities that customers' energy needs, power needs, but also can support the utility system's needs, and perhaps those of society as a whole. And so examples we have of DERs are efficiency and demand response programs, distributed generation, energy storage, and electric vehicles, either as just something to be charged up or possibly something to help manage the load. And then many people consider electrification in that category as well of DERs. And what's driving the interest in DER adoption today is really the opportunities that are coming from cost reductions in these DER technologies that are occurring, and the advancements in the technologies, the understandings by the marketplace of the opportunities associated with them. Customers are looking for choices for their energy supply and certainly looking for affordability, wanting lower bills. From the grid's point of view, the opportunity for modernization, improving reliability, and maybe even resilience. And then basically addressing the growing energy use, reducing demand through these use of these DERs. And there can also be other state or utility or customer tribal objectives that are being met by these as well. So first thing, maybe just sort of get you all thinking and perhaps chatting with each other in the chat box. Let me start off saying that, what the role of the DER programs are is addressing market barriers. And I'm going to talk a fair amount about that. What are those barriers and how these programs address that to accelerate DER adoption, if that's part of the objectives that you have. And then working to align the utility system benefits with the customer interest in that modern grid that we're building so that the DERs can benefit both the consumer and the utility system. And then potentially achieving broader societal benefits, perhaps improving air quality or supporting economic development. So a request for you all is, to maybe put into the chat box here a little bit about, how much you know about DERs and where you're at, whether you're just starting out with them, you're aware of them, but no particular programs, or if you're perhaps, deep into this or really getting into it. Maybe just share with your fellow fellows about where you're at, and that'll help me and Lisa as well to understand where we are as we go through this course. So, fundamental question here. So, if these DERs are so cool and wonderful and beneficial, why doesn't everybody just do that? So, the insight associated with that is that it's always about money. It's not always about clear benefits, and incentives are not always just the answer. The core concept here and why we have programs is that there's market barriers. And these barriers get in the way of making effective DER investment choices. And so what the programs do is provide the bridges to overcome those barriers. And so what are some of those barriers? Well, here's some of the classic ones that exist. And you're probably mostly familiar with this, in various other applications. Just basic awareness, are people aware of these opportunities, these resources existing? The information search cost, the difficulty in actually finding information. Probably the most common question I get if I mention to someone that I'm working on DERs or efficiency or photovoltaics, they'll say, well, where can I get more? How can I find out about these? Who are the contractors I can trust? It's just the pain and the difficulty of finding out information. And that's kind of associated with the next one too, the hassle factor, the transaction cost of actually going through this, whether it's a business or a homeowner, a renter, just all other demands on their life and just the hassle associated with figuring out who to call and the purchasing and perhaps permitting and installing. Then, of course, there's performance uncertainty, doubts about how these will perform. Another one that comes up, particularly within businesses, is the organizational practices. For example, budgeting cycles. You might be coming to a company with a program in June, and they go, yeah, that's interesting, but we set our budgets in January, and we already set our budget for the year. Why don't you come back and talk to us in 6 months? Or maybe they have a 2-year budget cycle. The next one, split incentives. This is a major one that we see within DER adoption. And that's, best example of that is when you have landlords and tenants. The landlord owns the property, would probably be responsible for any investments, but the tenant's paying for the utility bills. So the benefits and the cost are split. And this we call a split incentive. It can also occur with businesses, common leases with commercial property has the tenant paying for the rent, obviously paying for the rent, but also paying the utility bills. And then the big one that most people think about first, cost. What's the cost of actually getting into and investing in these DER technologies? So when addressing these, the way we go about it, and I'm going to give you a little bit of the theory side here with this kind of blue shaded box over here. And this is stuff that's kind of basic, logic, just logic makes sense, common sense here. But when you're designing a program to address these barriers, you want to come up with a theory and you want to come up with a logic model. These are again, the fancy terms used to describe, again, pretty much common sense. The theory being, when you go out and specify, if I do this, this is what the intended outcome is. And this is why there's a causal relationship, why what I'm doing is going to cause the outcome that I'm looking for. And again, even though it's common sense, it's a really good practice to just sort of go through the practice of writing it down of what we're going to do and how it's going to have the impact that we expect. And that fits in within that logic model which is, a way, diagrams usually of sort of showing the relationships between the barriers, the resources, the interventions, the parties involved, the outputs and the impacts. So, if you're talking with people about putting together programs, it's a very reasonable question to ask them about their program theory and their logic model. So let's get into these programs and, different ways to organize them and think about them and design the programs. So one thing we can think about is different goals. So two common goals for these programs is to transform markets, market transformation. And when you're doing there is really aiming to fundamentally change how the market's addressing the barriers that exist to DER adoption. So it's a broad way of sort of moving the whole market. Whereas resource acquisition is a term that's commonly used when you're focused really on just quantifying the quantifiable impacts in the short term. Basically, you want people to immediately reduce their demand during peak hours. And so you have a program that's focused particularly on the individuals that you're addressing versus the market transformation, which looks at the broader market, participants, non-participants. Another way to look at it, of course, is by sector. Residential, commercial, industrial, agricultural, or institutional, what we often call the MUSH market, the municipal, schools, and hospitals markets. Other ways to classify programs, and I guess clarify them as well, is by the target, whether you're looking at energy savings or demand savings or both. And then it's ancillary services, programs that are becoming, some instances, more important, looking to support, say, voltage or frequency support on your grid. Another way we look at these is by the time of intervention. This is a pretty common way to look at the program designs, whether you're looking at new construction versus retrofit, and whether you're looking at trying to get people to replace their equipment at time of failure. So the water heater goes bad, so your program's focused on replacing those when the water heater goes bad, or looking to encourage people to do early replacement and put in their heat pump water heater even before theirs fails. By point of intervention, and I'll talk a little more about this in a later slide as well, as to whether you're looking to work with, I'll start with downstream, that's the direct engagement with the end users, the customers, the consumers, or perhaps midstream, looking, for example, with retailers, your Walgreens or your Home Depot, or contractors or wholesalers, or upstream, just really looking directly at the manufacturers or the distributors, different points in which you can have intervention in looking to encourage, the behaviors or the actions, the investments that you're looking for. And then also by regulation is another way in which to put your programs together. Voluntary or mandatory, benchmarking, encouraging information to be provided out about, say, for example, buildings, performance standards, again, voluntary or potentially mandatory expectations for how buildings should perform with respect to their energy consumption, energy codes, of course, and appliance standards, whether federal or state. So some of the tools that can be used when you put together your programs, and on the left-hand box here, there's incentives. One that most people think about when they think of programs, providing rebates or grants or loans, perhaps performance-based payments. Rate design, the other probably most common way in people think about incenting DERs or other types of behavioral investments, basically structuring the electricity or the natural gas rates to encourage specific behaviors. Then education and training, and that can be for consumers or for contractors. Very common tools. There's programs such as building engineer certification trainings to encourage them and educate them on how to work their buildings so that they perform from an energy point of view more efficiently and effectively. And then RD&D, pilots, research, for the emerging technologies to test out these strategies. So on the right-hand box, I have an example with a heating, ventilation, and air conditioning program type. And, first, let's say that the barrier you really want to address first off is first cost. So I provide rebates, for high efficiency, HVAC units. For the barrier associated with performance uncertainty, you might want to work to build out a qualified contractor network, look to training and case studies, doing energy audits, that provide recommendations. That information search cost barrier, you could set up online tools, ones that are hopefully trusted by users, have a good user interface that allow people to compare their DER options in a more straightforward and easier way. And then that old hassle transaction cost barrier, certainly having an application and a process that makes it simpler, perhaps a one-stop shop type services. Combining these together to address the various barriers might be a way you put together that HVAC program. So with that, where do we start? How do we get going with all this? And what that relates to is the question that maybe people will be asking, which is how much is out there? What's my potential? How much could I achieve? What's realistic to expect? And the answer is you start with a potential study. So a potential study is basically, hopefully a comprehensive, but an analysis that estimates what we call the technical, economic, and achievable potential for the deployment of what you're looking to achieve here, within a specified area, service territory, or over a specific period of time. And to put that together, you need a bunch of baseline energy use data. You need to understand the technology, characterizing the market, which technically means looking at how much of the technology or the strategy, the behavior is already exists, and then looking at various customers and doing modeling based on the experience of different programs to come up with an estimate of what the potential is that's out there. The folks that conduct these studies tend to be specialized consulting firms that do this work around the country. And on the right-hand side here, I have a little graphic to try to define what I mean by these three levels of DER potential: technical, economic, and achievable. We start with technical, and on the graphic, that's that green curve at the top there over a period of time. And that would be if you could do everything that's technically feasible. Let's take insulating attics in homes. If you did an analysis and looked at how much insulation could I put in if I could put insulation in every single home in the area that I'm interested in, that would be the technical potential. Economic is, of all that, what would be cost effective? Not everything that's technically viable is economically viable. And we're going to be talking about benefit cost analysis a little later in this session. And then the last one is achievable. So of that technical economic potential, what's actually realistic that can be achieved considering all the factors that are involved here? That technical and economic potential tends to be a little more straightforward in analyzing. The achievable tends to be a softer number because it's estimating what you think people's behaviors are going to be. And you're going to rely on that based on previous analysis and expectation, the experience of the firms. I remember in one situation, another colleague and I were working with a working group actually in the state looking at developing programs, and they were asking us about achievable and asking us about the process. And the two of us looked at each other and we started waving our hands as sort of a description of coming up with the achievable. It's better than that, but just realizing that when you look at, estimating the future, it's always difficult.
Hey, Steve, we have a question
Sure.
on that slide.
Sure. Let
The
me
question
get back
is,
to it.
should the technical potential be the top series and the one on the bottom achievable? In other words, are you just checking? I
Look
think
at
that is
that.
correct.
That is
We
correct.
realize that we
So we
both.
did that. So I did that merely as a test to see if anyone
Okay,
was
all
actually
right,
looking at the graphic.
good job.
Thank you for those who are looking at the graphic. Yeah, that's
So we'll
boy.
post a corrected version of this, Steve.
Yeah, we'll do a corrected version, and I'm going to have to look at the handbook that I think I grabbed this from and make sure it's correct in there. Okay. Oh, well, the test worked. You guys are watching. Thanks for keeping an eye on things. Appreciate that. Okay, so let's now turn to some program mechanisms and hopefully no more errors in my graphics. So what I'm going to do is talk a little bit about some of the mechanisms that are used in programs, financial incentives, the rate design, technical assistance, market transformation, and pilot programs. These are ones I mentioned earlier, but I'm going to try to do, I think, a slide about each one for you all. So financial incentives. And this is what most of us think about when we think about programs and what we're going to do, basically to address that first cost price premium of doing something that's more efficient or putting in demand response, thermostats, controls, distributed generation. So two ways in which those are typically done is just simply an upfront rebate, a direct payment that's made to offset the cost that someone's going to have associated with the DER adoption. Another way is to do performance-based incentives. And the popularity of this approach sort of ebbs and flows over time. But the idea here is to actually provide payments based on the performance, the actual energy production, for example, or the amount of demand saved over a period of time. So you're not paying right up front, you're paying for performance. And that's basically what these are called, paid for performance. These are probably most popular right now with demand response programs where consumers or businesses sign up for programs where they can voluntarily reduce their demand at the request of the system, of the grid, when there's a need. And depending on how much they reduce their demand, they get paid when they actually deliver. Now, most of us, again, would probably think of the payments going to the consumer, to the utility customer, but they don't have to do that. You don't have to do that. You could also give them to retailers to reduce the cost at the point of sale. You could give incentives to contractors, installers, designers, to have them encourage their customers to put in these types of equipment. Or, of course, to distributors and manufacturers, programs to encourage them to stock these DERs so they're more readily available, or to manufacturers to develop these types of DERs if they fit within the objectives of your jurisdiction. The other one that's probably most popular is just rate design, where either natural gas or electricity rates are designed in a manner to encourage specific behaviors. So, the one that probably most of us think of is having prices different, whether it's a peak period or off-peak period. But there's a whole range of ones that have been done. And I know the Berkeley Lab has done a number of studies and reports on these in terms of, using rate designs to encourage, shape behavior based on sending price signals to the end user. Then the bottom box here, another approach is obviously education and technical assistance. As I mentioned before, providing guidance, materials, outreach, whether that's for the consumers or for the workforce that actually goes about the process of designing, installing, or maintaining this equipment. And the idea there is to address that barrier associated with just not having the resources or the background, the knowledge to move forward with the DER. Again, program types here, rate design, education, technical assistance. And then there's this market transformation. So again, the purpose here is to really remove the structural barriers in the marketplace so that the growth of the technology or the practice that you're interested in is accelerated, perhaps faster than it would naturally. So on the graphic here, and I think this one is actually done correctly, where you have with what's called S curves, even though these aren't very S-like. These are, the sort of standard curves that demonstrate over time the adoption of any technology, whether it's, your mobile phone or a heat pump or LED lamps. You have a baseline market adoption that would occur naturally in the marketplace. And then the orange line is a faster adoption rate, the market transformation units being the difference that are encouraged based on the program. So what you're looking for is adoption of a technology or practice that just becomes normal of how the marketplace operates. This might occur over time. Again, relatively recent example of mobile phones, where it just becomes common practice. If you're interested in a certain technology, a DER becoming common practice, your program can be about accelerating that and having it happen faster than would naturally occur. And so these interventions that you can do tend to be focused at the supply chain. You can work with the consumers, but there's more of a tendency to work with manufacturers, distributors, contractors for a larger impact. And if you do work with the consumers, you're not just looking at the participants, you're looking at everybody, whether they're currently participating in a specific program or not. And examples, as I sort of mentioned there, that have seen this, sufficient lighting, refrigerators, certainly heat pumps, thermostats, smart thermostats, for example. And one of the most common mechanisms that I use as an example of this is if you're giving our distributors and retailers incentives to stock the efficient models. Getting back to the case where I talked about where you want to have, say, more efficient water heaters going into homes. Typically, people buy water heaters when their water heater fails. They call up a plumber, they call up, Home Depot and say, "Hey, I need a new water heater. What do you got?" And if they say, "Well, I've got the standard one right here, I can have it for you in an hour," versus the efficient one, which I'll have for you in 2 weeks, you're going to go for the one that you can have in an hour to have your water heating. But if the Home Depot, if the contractor has the efficient ones on their truck as well, you might be more encouraged to install it. So these are kind of market transformation mechanisms that you can use as part of your program design. The other category that I mentioned was the pilot programs and doing research. These are types of programs that really test out the program designs, the technologies, and the market approaches. And basically, the benefit here is you gather the information to help you with future programs and show you, what can work or what doesn't work. And so you can have decisions about how to move forward to get to a broader impact as a result of learning through this pilot programs or the research development and then demonstration. So some other strategies, in addition to those programs that I mentioned, is benchmarking. Basically policies that require or encourage people to report the energy use of buildings, data, information that might be useful for tenants that are looking to rent buildings. They're going to be paying the utility bill, so having information can encourage the landlords, whether commercial or residential, industrial, to have more efficient buildings because that information is going to be out there. And that can be one of the decisions that consumers use when trying to decide where to rent a building, for example. For building performance standards, these again, voluntarily or mandatory, set minimum thresholds for performance of buildings, particularly existing ones, whereas the energy codes tend to be associated more with new construction or as a result of doing major renovations to existing buildings. And then appliance standards for particular pieces of equipment, such as refrigerators or lighting as a state here. And these can be done by states as well as by the federal government. States, if there's not already a federal standard currently in effect. So let me take a sort of a quick break here and just again give you the opportunity, if you'd like, to put into the chat box, or if folks want to speak out a little bit about what their thoughts are about the barriers that they're facing within their areas, within the work that they're seeing, and perhaps what kind of mechanisms that they would consider appropriate, that they would consider in putting together. Again, you're welcome to put your thoughts in the chat box and share that. Lisa, if you're watching, if there's someone who's in particular like to sort of talk a little bit about what they're seeing, we certainly can take a little break here.
Sure. If anybody wants to raise their hand, so we don't have people talking over each other, we can call on you and you can take yourself off mute. Also, feel free to put anything in the chat to share with everybody. And we did see in the chat box earlier that some of the fellows are actively already implementing DER programs. So it'd be good to hear what barriers your programs are trying to get over and what are some of the mechanisms. And again, either raise your hand or put it in the chat.
Okay, well, let me keep moving here, but certainly feel free to use the chat box or raise your hand and we can go. Okay, so next up, so talked about some of the mechanisms and approaches and ways in which you can, influence behaviors, investments, for example. So I'm going to talk a little bit about the design elements and the life cycle and the key considerations. I'm going to go through a bottom-up approach for program design. And then there's three other areas that I wanted to mention, just sort of important considerations when you put together programs, really considerations and opportunities. So program lifecycle. So I'm going to be talking a little bit about this, throughout the session, the presentations I have today. But, really what we've got is a continuous process here where you're planning, you're implementing, and you're evaluating. And I put this figure here so just sort of remind folks that, it's possible you're doing a one and done program, but in most places, you're using, a one program, a current program to sort of, test out, see what's going on, learn from, and then if you're continuing the program, through the implementation and evaluation process, you're learning and you're adjusting and using that opportunity. And so some of this is kind of obvious, but it's just sort of a good reminder that you really have a process, a continuum here of planning, then implementing and evaluating, and then using that information to make yourself more effective, to make your programs more effective. So here's kind of a long list of considerations for program design. Uh, Things as sort of a checklist. And again, you'll be having these slides, and if they're useful for you, hopefully it's sort of a checklist for things to think about. Again, somewhat obvious, these are the potential contents of the sticky notes. What's your desired impact? What do you want to achieve? Do you want to get a certain amount of energy savings? Do you want a certain level of participation? Who are you going to be targeting? Is it, residential, homeowners, small businesses? What are the measures really? What are you trying to align? You probably start with an objective of energy savings or demand or ancillary services, deciding which technologies, which, in this case, DER programs or programs or strategies are effective. And then identifying those barriers, as I've talked about, and you will see, what are those barriers to, adopting those measures you're interested in, achieving those impacts you're interested in, and then developing the program theory and logic model, addressing the incentive structures, what kind of technical assistance is needed. Certainly going through and doing outreach campaigns. These are efforts that, in particular with these types of programs, people are not waking up every morning going like, gee, I wonder what kind of DER I'm going to install today. You have to go out and inform and engage the consumers, your target audiences. And then, how are you going about monitoring the effectiveness? How to track the progress, looking at the cost effectiveness. You're going to project that in the planning process, but do you want to look at the cost effectiveness as you're going forward? And potentially adapting things as you move forward. So this is another way of sort of presenting some of the similar points here, but just sort of again a possible checklist, for what I'm calling a bottom-up approach to program design. Starting with your goals and assumptions, which tools you're going to employ, coming up with your budgets, doing the cost-effective analysis, how much of funding is available, and what approaches are going to be cost-effective. Putting together your flow diagrams or whatever way you want to describe that about the process and way this is going to work. The applications and the approval, the installations, the inspection. Going through those. What time frame you're looking at? What sort of milestones do you want to have for checking in to see if things are performing as expected? If you're going to have program, you're going to have eligibility criteria, who's qualified for the program, who can participate, who are your partners, who are you working with, where are their roles and responsibilities. I have a little more about that coming up. And then again, the outreach, marketing, communication strategy, how are you going to reach your audience? Couple of points. I'll just sort of leave this up here for a moment. And again, these slides are available, but hopefully somewhat obvious points of, the importance of budgeting and having risk management, looking at that budget and the cost effectiveness. Again, that's going to be another session coming up this morning, this afternoon here. But also looking at your risk management. What are the risks? What are the potential challenges to which you put together, and what are your strategy for addressing those? And then even as you're planning the program, how are you going to evaluate? How are you going to determine, measure, and verify the performance, the effectiveness? And again, we're going to talk about program evaluation actually next up. And then it's nice to have an exit strategy. Something that we all know sometimes is forgotten about is, what is the end point? When we get to this point, how do we end this program in a sound manner? And when I'm talking about risk managing strategy, another way to think about that is adaptive management and having your key performance indicators, your KPIs, and looking to be prepared to adjust the program based on what you find. And part of that is having these KPIs, these key performance indicators, such as are you getting the volume of customer participation that you expected, and if not, why, and looking into that. And and one way in which this can be very helpful and done actually is to make sure you have transparency in your reporting and that you budget and plan for that so that it isn't just seen as a extra expense and a pain in the neck, but it's part of the actual program implementation that you know that this reporting is going to occur and you're going to use it and take advantage of it for your adaptive management. Sort of switching gears a little bit, another point I wanted to talk about is non-energy benefits. If you're looking to benefit the utility systems, the grid, the electricity and natural gas systems, most of us, we're going to be focused on those quote unquote energy benefits. But for consumers, the ones who are participating in DER programs, they're often looking for other benefits beyond the energy benefits. And some examples of those are improved comfort or productivity, health benefits, increasing the property value, having reliability benefits of, during power outages, or, feeling a sense of environmental stewardship, feeling pride in participating in that, or just having enhanced control over their energy infrastructure at their own facilities. So what we see, I often see in running programs, implementing programs, in my own personal examples in my home, I live in a very moderate climate. We put in energy efficient windows. The payback was probably 7,000 years. But what I got out of it was some energy savings. But what I really got out of it was less drafty house and a quieter house because these windows were, better windows. And that's what drove my decision, even though, for me, there was long benefit, long payback, but it also reduced, the demand on the system and helped the grid as well. So think about non-energy benefits. I just want to make sure to have that point for you. Another point I want to have sort of, on the side here is thinking about the trade allies and the engagement points that you have your program. You're not on your own. When you're doing programs, there's going to be other participants that are looking to get benefits out of this. And these can be your trade allies. And that's the contractors, installers, the vendors, the engineers, the architects, the service providers who work directly with those who are implementing the program, implementing the DER. And so working with them can really be key to program success. Understanding what their barriers are, understanding their delivery channels, really plugging in so that you can work with them as the actual deliverers, in many instances, the influencers that help consumers make decisions. And so investing in those trade allies, listening to them, understanding what their needs are, and partnering with them can be a really important and effective way to develop and implement your programs. And where, again, you can interact with them is downstream, whether it's direct customer engagement or potentially directly with their contractors. Midstream, again, thinking there, the distributors, the retailers that sell the products, or then upstream, where there's fewer market actors, so you have a smaller audience you need to address, but they're, a key component of that. And, that's typically the manufacturers. Next, getting to roles and responsibilities. What are the roles that exist within these programs? And then what's the task that those of you here who I think might have some oversight responsibility, what are your roles here? So the roles that we see within programs is that oversight responsibility. And that's, the regulatory bodies or some agency or tribes, their public utility board or your co-op that's really responsible for establishing the program frameworks and setting the requirements, et cetera. That can be the same as the program administrator, or it could be someone different. The administrator is someone who's actually responsible for achieving the program, actually designing and implementing that strategy. And that can be someone that the oversight or authority oversees, such as a utility or a third party, or it could be the oversight authority themselves. And then the program implementer. This is the entity that's actually responsible for the day-to-day execution. Again, these can all be aligned or even the same party with the administrator, or even the oversight authority, but often it's separate. And of course, the program participants, and then your evaluator. Evaluators, again, can be independent third parties, or they can actually be the administrator. This decision, we'll talk a little bit in the evaluation session about the advantages or disadvantages of having third parties, versus the actual ones administering or implementing the program, doing the evaluation. And then, as I mentioned before, all those trade allies that can be part of this program role. For the oversight responsibility, it's really the goal here is to provide the strategic direction and the accountability, establishing clear frameworks, guidance and direction, facilitating the stakeholder collaboration, which you can have, certainly suggested to have to engage the stakeholders, whether that's the consumers or, as I was mentioning just before, about working with the contractors who understand the mechanisms that the customers, the consumers use to decide on making these investments and working with them. Reviewing and approving the program proposals, that can come from those administrators or implementers, and then the monitoring and oversight responsibility, ensuring the compliance with, the requirements that you've established and the program rules that you established to make sure that there's value being provided and the expectations that you have are being met. So in summary, for this part here on the program design elements, when you're looking at successful DER design, it's crucial, for really modernizing our grid and empowering consumers and achieving reliability and affordability goals, meeting the goals and objectives of both the utility system, whether it's natural gas or electricity, the jurisdiction, the state, their objectives, and to consumers as well. And so that requires our understanding of the market barriers, the mechanisms that you can use, the tools available, and the idea of encouraging the continuous adaptation of these programs to meet the changing needs and as they occur. So you want a set of objectives and goals. You want to ensure a cost-effective value proposition, and you want to, in that implementation, identify the roles, align the goals, identify your risks, come up with risk mitigation strategies, and then incorporate the evaluations and the feedback.
Hey, Steve, I want to bring up a question that is a good one for you. Someone who's at the Hawaii PUC, where you have worked, talking about, seeing success in adoption of DERs at the residential level, solar and batteries, through their, bring your own device program as well as other programs. But those programs are disproportionately benefiting customers who can afford the initial investment and maybe don't need that, bill support as much as some lower to moderate income customers. Have you been part of the design of programs, or are you aware of any programs that are able to address some of these socioeconomic barriers of DER adoption?
Yes, and yes. So there's a whole segment of the DER industry, and I would say in particular for energy efficiency, but increasing interest in storage and distributed solar as well, in working with low-income consumers. And so there's basically a low-income energy efficiency, in particular, industry that exists and works on those barriers. Certainly, the first one is going to be the cost barrier. Those programs tend to cover 100% of the cost of installing, the efficiency measures, more efficient air conditioning, insulation, shading opportunities. But because of, the audience that you're looking at just is not going to have the financial resources, those tend to pay 100% of the program costs. But that's not the only barrier. The barriers that I mentioned before, I don't know if I can quickly, without making myself or anyone else dizzy, looking at that list of barriers, these barriers apply to really all consumers to one degree or another. Split incentives, for example, a lot of renters in that community that you're talking about. And so what you need to do is to really work with the landlord communities and find a way to get them and encourage them to make the investments in their property. And there are mechanisms to do that. There's sticks and there's carrots, of course, as well. I would say the information search costs and the hassle, there's also a large trust factor. A lot of work that I've done, people have felt like they've been taken advantage of many, many times over. And so it's really finding trusted advocates in their community that that these consumers feel comfortable with and working with them, whether it's nonprofit community organization or various trade groups, that there's a comfort level so that there's trust can occur because, you know, in disadvantaged communities, low income communities, folks have been taken advantage of over a long period of time. So their trust that you're coming in and saying you're going to help them reduce their energy cost, can be met with some pretty raised eyebrows. And so finding partners that you can work with to help them understand the opportunities and the needs and what the options are and to work with to work through that, process of actually getting these implemented, addressing their needs, listening well, and often very much so addressing the first cost barriers.
And
So that's
Steve,
those few things.
we should move on given the time, but I
Yeah.
just want to note that yesterday when we had our energy affordability session, we did talk some about community solar options, so that we did discuss that as well.
Okay, great. All right. Well, thank you. Hopefully that was helpful. And we're going to move on to evaluation. And let me just make sure I pull up the right set of slides here. There's one more here. There it is. Program evaluation. Okay. Okay, look, once again, we've got it starting at the very end. So let's push the right button here. Go to.
Before you do that, you might click on the left side to slide 1. It might be easier. And
Oh,
then
that's probably going to be much easier. Thank you. There we go. Okay, here we go. Okay. So, talked about designing these programs, and now let's talk about evaluating them. So, first, a little context and some definitions. Talked a bit about this before, in that what you're looking to do with your programs is accelerate some actions by market actors, and it starts with coming up with ideas and researching them and demonstrating them, and then doing voluntary deployment, and then potentially looking to work towards some sort of transform markets, so you don't have to do these programs where things become standard practice or maybe embedded within codes and standards. And the evaluation process is something that supports this. It's a tool to support these actions, provide information and feedback so that we can do these more effectively. So why evaluate then? So it's to document impacts. It's basically providing proof of the effectiveness and the responsible use of DER investment dollars. It's useful for resource planning. It's providing the data to support future energy infrastructure investments. Understanding how, in this case, DERs are performing tells the system planners that this is a resource that can be counted on, it can be counted on for so much, or is a reasonable way to continue to make investments as one of your alternatives for energy infrastructure development. So it's for resource planning. And then understanding why the effects occurred. Basically, it's really to this little graphic here and to the one I mentioned before earlier in program planning. The evaluation process identifies ways to improve current and future programs. You can't manage what you don't measure, and things that are measured tend to improve. That's why we're doing this. But the scope can vary depending on what your evaluation perspective is. You have specific, programmatic and regulatory contexts, whether it's performance mandates or performance incentives, scale. So how the evaluation results will be used. So in this example here, I got 2 different states. State A here has unlimited goals. They have no performance incentives. They don't really have big expectations for their DER activity. In that case, maybe you just need minimal evaluation. Whereas state B, there's long-term savings targets. They've got incentives for those involved in the administration. And there's a need for solid savings data because they're looking to resource planning. Thus, you might have a substantial evaluation. One size does not fit all. You have to look at things, and we're going to talk a little bit about that. So the types of evaluations that exist out there is 4 general categories. We're going to be focusing today on the impact evaluation and then the benefit cost analysis. So impact evaluation is the one most of us think about. It's really the quantifying the direct and indirect changes associated with the program. For example, how much energy was saved. Process evaluation is looking at how the program's working. How are the processes? Is it working well from the consumer, from the contractor, from the administrator's point of view? Basically, there to improve the program and make it more effective. The market assessments, that includes the potential studies that I mentioned before, but also just all kinds of studies to look at how the supply chain, how the market is changing as a result of your program. Basically characterizing those markets that you're working in and seeing if your programs are actually having an impact, as well as the ex ante estimates, the potential studies. And then the benefit cost analysis, so, form that sort of fits within the impact evaluation, but basically quantifying the cost of the program and comparing that with the benefits to see whether you're doing cost-effective program designs or if your program you implemented is cost-effective. Some of the definitions we see is just evaluation in general. It's the studies and the activities determining the program or the portfolio level. You often heard the term measurement and verification, and that, in common practice is really associated with assessing the performance of individual sites or projects versus the evaluation is a more general term, looking at programs or portfolios. And then there's EM&V, this catch-all term that really refers to determining both program and project impacts. Verification, that's a sort of a subset of this, and this is the idea typically done by an independent entity, but done by someone to ensure that the DERs in this case have actually been properly implemented and can generate the predicted impacts that you would look at from the overall EM&V process. When to evaluate? Well, again, I'm kind of a broken record here. The evaluation is integral to this planning, implementation, evaluation process. And really what your best practice is to produce evaluations within the cycle or soon after the cycle of implementing a program. And the reason for that is to provide timely information, so you can actually maybe improve the program as it's ongoing and support really the future planning and new programs. If you end up doing an evaluation and it's 2 years after the program ended, it's really not particularly helpful. It's something that often will just end up on the bookshelf. So doing sort of an ongoing evaluation process and informal evaluation processes, at the conclusion or soon after is a really useful way to do that. Because basically you're using the evaluations to update, what you're doing at the current time and to update your plans for the next cycle of a program. What we see when we're getting this evaluation is really 3 categories of estimates, certainly associated with the impact evaluation. When you're planning the programs, you have projected savings. That's what's coming from your potential studies, and whether it's individual estimates or the program overall estimates. So that's projected savings. And then as you implement the program, you get claimed savings. These are savings that are claimed typically by the contractors, implementers of the programs. And then you have the evaluated savings, which are the reviewed savings or the independently developed savings done by potentially a third party or someone, the administrator, working to come up with a separate indication of whether what savings occurred. So you start with projected, you get claimed, and then you evaluate the savings. So what are some of the issues associated with doing all this? Well, here we go. All right. So here we have a graphic that's showing in a energy use in a building before your DER project's implemented. Then you have the installation. Then you have the energy use afterwards. In this case, hopefully somewhat lower energy use afterwards. And you want to come up with the savings. As the subject line here shows, these savings actually can't be measured because what you're doing is you're estimating the energy use without the DER project or the DER program. And there's no measurement to be made here. This doesn't exist. That building that you retrofitted has been retrofitted. Unless you have a parallel world somewhere, there's nothing to measure. So you're going to have to estimate, and we're going to talk quickly about what are the ways to go about doing that. So what you're going to do is you're quite possibly going to be able to measure the energy use after the project, but you're going to have to estimate what would have occurred in the absence of the project, what we call the counterfactual, in order to get your energy savings. So that really creates the dominant EM and V issues, the evaluation issues. If you're going to be estimating, how good is good enough? It's really the fundamental issue I like to think of. How much effort do you want to put into obtaining that level of certainty associated, with the savings estimate versus the value of the information? And that comes the key question is what are you going to use that information for? How important it is? And it gets back to that earlier slide of understanding what your objectives are in your situation helps you feed into this answering this question of how good is good enough because that EMV should be cost effective as well. What it ends up meaning is that your evaluation process, your EMV, is about managing risk of the uncertainty, risk of not achieving the impacts that you expected. And so you got to determine how good you need to be about that. The second big question is as compared to what? And there's two ways to look at that. As compared to what? The first is the level of performance, the impacts associated with those DERs relative to your other resource options. In virtually every situation, it's not, am I going to do DERs to meet my energy needs or nothing? You're going to meet your energy needs. So you're going to be looking at other options. Maybe that's a central power plant. So it's the performance confidence. What's the performance of that DERs compared to other resource options, given all the costs, benefits, and risk? So that's one and first way to look at, when you're comparing these options and getting your evaluation results. The other is the more fundamental one of establishing a baseline, what we call the counterfactual. From that prior graphic, what would have been the energy consumption of that building in that example in the absence of the project. So you need to come up with, if not the DERs, what the impact would be. And that creates that estimating, and that creates the question of how good is good enough. And it creates the evaluation challenge because essentially evaluation attempts to measure what didn't happen. And for some group of us, you'll recognize a movie that was made about this very subject. Little different context though. So with that, what are the metrics? So if we're talking about impact evaluation, and that's really, again, what I'm going to be mostly focusing on here, you have gross impacts and net impacts. Gross impacts are the energy savings, for example, versus the demand savings that result directly from the program promoted actions taken by those participants, regardless of whether the program influenced or not. It's just what happened by the program participants. How much energy did they save, whether the program influenced it or not. Whereas the net impacts, they're about the portion of those gross savings that are actually attributable to your program. And attribution is the term we use there, the attribution associated with the program. Some EM&V methods provide gross impacts, some provide net impacts, and sometimes when you just have gross impacts, there'll be a factor that's just added in to come up with a net value. And that gets us to that how good is good enough thing. So many of you have probably seen something like this before. Pretty much every time you've hired a consultant or a contractor, they've come up with something pretty similar to this, saying that, there's three factors that determine, the effort: quality, cost, and time. And you can usually control two of those, but not three of those. So if you want high quality and you don't want to do it very expensively, it's probably going to take a while. Whereas if you want it good and quick, it's going to be expensive. And if you want it quick and cheap, you're probably going to get poor quality. So these are the trade-offs that you're going to see. And this is going to be my next opportunity for you to maybe share some thoughts among yourselves in the chat box, or if someone has a particular comment they'd like to make about, how do you look at your perspective? Where are you all at, and the importance of having strong evaluation results, high quality ones. What's the importance of quantifying those impacts versus, the importance of balancing cost and timing and quality. So if you like, add your thoughts in the chat box with your fellows and, think about this, because as you put together really your programs and your evaluations, these are the three factors that you're going to be balancing. Leave this up for a second. Okay. So let's talk about those methods for evaluation, perhaps while you're doing that. So three primary impact evaluation metrics. There's measurement and verification. And as I mentioned before, when in definitions, this is about, looking at determining the savings for individual projects or, a particular facility. And that involves some level of measurements. Another approach is called deemed savings. And this is where basically you use historical data to come up with values for what the savings are. And then the third approach is comparison groups. This is the really preferred approach, but often difficult to implement approach of using analysis. This is, what many of us think of, say, for example, with drug trials or testing out, control groups. So I got a slide or two on each of these for you. So this project-based measurement and verification determines gross impacts. It's a method for doing gross impacts. Usually involves the utility revenue meter for getting the data of the source of, say, what the energy consumption is in the factory or the home or the commercial building. And basically with this M&V, this measurement and verification, something's measured. But default or stipulated values can also be used. You might not measure everything involved. For example, you might not measure the weather. You might just have, weather data that's available for a deemed value. You might not measure how long the equipment lasts. Some of this equipment is going to last 20, 30 years. You're not going to be measuring it for that period of time. You might take measurements for 1 or 2 years, maybe for 1 week, and then assume a certain useful life for the long-term projected savings. So basically with measurement and verification, to come up with the program savings, you're going to look at the savings associated with each individual project in a program, but that's really done just with a limited number, say, of large industrial or commercial projects. Or more commonly, you select a representative sample, say in a residential program that might involve thousands or tens of thousands of individual projects. You select a sample, representative sample, hopefully, and apply those savings for the whole program. And your basic measurement verification equation here, I think perhaps one equation in my presentations here, is that your savings is equal to the baseline period energy use, that estimate, minus the reported period energy use, plus any adjustments that might have to be made. And those adjustments can be routine, such as changes in weather or occupancy, or non-routine because the building use changed. You did the energy retrofit in a building that used to be commercial retail space, and now it's residential occupancy. These create the challenge because, again, you can't measure what's not there anymore. You can't measure, what would have happened in the absence of that because it doesn't exist anymore. The deemed savings, and these are used almost exclusively for efficiency measures. They're also just called stipulated savings. And these are values, say, per unit energy or demand savings that are applied to very specific, well-defined, say, energy efficiency measures. So for example, the annual energy savings, kilowatt hour savings per year for a defined LED, a lamp type in a defined application. So you say if you are putting in 7-watt LEDs into hallways in residential apartment buildings, those will save 42 kilowatt hours a year. And these also can be used for deeming the measured lives as the example I did, or avoided air pollutions. And these are really only useful for well-known and well-documented measures. These should not be used in places where really there's a lack of certainty associated with that. But there are a number of measures where that is the case. Over time, there's been a lot of LEDs installed. There's been a lot of, refrigerators installed. There's a lot of documented results. And so it just might make sense and be very cost effective, certainly provide a level of certainty of not going back out and measuring the savings from every refrigerator retrofit program. These deemed saving measures, they're based on previous evaluations and studies. You might have a separate verification process. I defined verification for you before about verifying this actually installed or a sample are installed. And usually, at least for efficiency measures, as I mentioned, it's usually used with efficiency measures. These are often documented in what's called technical reference manuals, TRMs. And many states and utilities have these. And the Berkeley Lab actually published a guide for these, a little dated, but still, valuable for describing TRMs, and how to use those for your deemed savings value. And then the third method, the comparison group method. So the basics of this is attempting again to measure what would have happened. By that, you're basically comparing the outcome for a group that implements the DERs, the treatment group, using say pharmacy drug trial term, with a group that does not implement the DERs, the control group. So you have a treatment group and a control group, and you're basically doing is comparing, say, the energy use over time of those two groups, or the demand, performance of the DERs between those two groups. So basically, what we're trying to do with the control group approach here, the comparison group approach, is to isolate the effects of the DER from all other factors that might influence the outcomes. Changes in occupancy, changes in rates, energy rates, changes in weather. The only difference you want between the two groups is that one group implemented the DER and one didn't. So basically, that control group serves as your proxy for that unobservable counterfactual, to use fancy terms. And if you do this well, it's really the gold standard for determining impacts. The two approaches used, randomized control trials, again, this is what's used in testing out drugs, is participants are randomly assigned to either the treatment group or the control group. That really minimizes the differences. This isn't always possible, so you have this fancy term of quasi-experimental designs. And basically that means that your control group is selected in a different manner that is trying to get as close as possible to random assignment, but isn't able to quite do that because of various situations that are occurring. And so you might have a control group that's based on those who have not installed the measures in yet, but are going to be installing it next year. So those control groups, it's again the most reliable way to determine the impacts of participants attributable to that program treatment. So if it's really the best way, why isn't it always used? Well, what that means is when you do this, when you select consumers to not participate, you're basically telling some of your utility customers, some of the consumers, that they can't participate in a program. And there can be some fairness issues to that, but also just why would you want to separate out a group of people that you want to actually participate in the program? And also establishing that control group can be hard. It requires a fair amount of data to really get the groups together and to work through that. It's not necessarily easy. Getting data access to the participants is usually fairly straightforward because they're participating in a program, but getting data access to the people who didn't participate usually requires their agreement to do that, and that can be complicated. Now, these control groups, they get you net impacts. Sometimes people are just interested in the gross impacts. They're really not interested, it doesn't really matter that much for their objectives as to whether they know the net impact. So, and the deemed savings, well, some people who are doing programs, they just really like certainty. The deemed savings provide certainty. You know upfront that if you replace 10,000 LEDs, what the determined deemed savings are going to be versus waiting to the end of an evaluation with a control group to finding out what the impact is. And that certainty can be very appealing. So some applications, I've kind of touched on this as I've been describing them, but the measurement and verification, that second column here, this is for simple, well-defined measures. It's commonly used when you have utility 15-meter data available. And its efficiency. It's really not particularly applied for complex programs and such. Whereas the comparison groups, if you have well-defined measures, you're going to use deemed savings. If it's complex, unique DER measures, it's just going to be impossible to come up with control groups. And so where you're really using the comparison groups is with, say, residential new construction efficiency programs, distributed PV, demand response programs, in some cases distributed storage, where you have large numbers of participants and it's possible to pull out a control group. Evaluation frameworks. So as you get into, here where we're talking about, how you're going to actually put together your evaluation strategies, a way to do this is what we call an evaluation framework, and basically providing the guidance on your objectives and process and activities. You're going to document basically, these principles, your objectives, your budget, your schedule, roles and responsibilities. And they basically become the functional document that's your strategy. And again, Berkeley Lab has put together a guidance document that's available online to talk about how to put together these frameworks for guiding your DER evaluations. Roles and responsibilities, touch on this a little bit before, but one of the things you're going to need to do is define who is responsible for that evaluation effort. Basically anybody can do the evaluation. The ones who are administering it can do their own evaluations. The implementers can do their own evaluations. But sometimes, it's going to be a decision made that you want some sort of independent or third party to come in and take a look at that. And that third party evaluator is basically an external body that, really primary role is to conduct the evaluation in an impartial and objective manner, basically not having, at the minimum, not having any financial connections associated with the outcome associated with it. So that's primarily an issue for the impact evaluations. For the process evaluations is one of the categories I mentioned before. Those will tend to be conducted by those who are implementing the program, so they can more directly use those to sort of help them directly apply how they're learning about how their processes are working. So in summary here, these program evaluations, they solve multiple purposes, document the impacts, support, it says electricity, but it's really support your energy infrastructure, whether it's electricity or natural gas or other resources, planning, providing understanding of why the observed effects occurred. They can be impact evaluations, process, market, benefit cost analyses. They all have valuable uses. There's a lot of approaches for doing this. You got to pick the one that works best and is cost effective, manages your risk. Your key challenge is going to be establishing the baseline, or if you want to talk fancy, the counterfactual, and really deciding how good is good enough so that you have a cost-effective and useful evaluation. And that framework, that guidance can be an effective way to put that together. So with that, let's see, Lisa, if we have any immediate questions or.
We don't right now, so I think we can just roll into benefit cost analysis. If you have any questions, feel free to put them in the chat or raise your hand.
Okay. So it's time for me to, again, find the right slides to share here. And there they are. Let's see. Oh, look again. Okay, let's start at slide 0. All right. So one of the ways to evaluate and to help design your programs talked about is benefit cost analysis. And that's what we're going to chat about now for the next, 20 minutes or so.
And Steve, before you do that, there's a question. Are you aware of any resources that can streamline M&V, such as creating a counterfactual scenario?
When I think of processes, yes, there is. There are. Well, the process itself, in terms of streamlining, it takes time. In terms of there are tools out there that can help do the analysis quickly and help gather the data quickly. And these are tools, some of them are publicly available, some of them are the tools that the firms who do this kind of work, there's a range of consulting firms that this is their business of doing evaluations, impact evaluation. They have their own tool sets. And so what their tools and their analyses can do is say quickly gather up, they say the utility revenue meter data and do the analysis and quickly come back with what the impacts are, whether you're using just a development of a baseline from the data, say, before the project was installed at a particular facility or using control groups. So there are tools out there. I think some of the Berkeley Lab reports from our building technology division provide some summaries of those tools, but also online. It basically, I think if you did a search for the firms to do that, but it's really tools that exist that the firms have. And then, of course, the most streamlined is going to be the deemed savings, where you just simply say upfront, if we're going to have a program and we're going to be installing these, um, you know, certain types of refrigerators, and for every refrigerator that's installed, we're going to assume that it saves 327 kilowatt hours a year on average. Some of them will be more, some will be less, but based on prior studies of refrigerator retrofit programs, we think 327 is a good number. And the only thing we're going to do is verify that they're actually sold and at the retailer, and then you're very streamlined. I feel like I didn't fully answer the question. The tools exist out there.
Steve,
It really depends on
I
the
put a
approach.
link to the handbook by the NSPM on the methods, tools, and resources.
Yes. So that's really for the determining the values for the benefit cost analyses, but that is very much related as well. So that is certainly one of the resources. Thank you, Lisa. And certainly, Lisa and I, we provide our contact information here. We're here to support you all. Some further information, or if I can help with some resources, just drop me an email. Okay, whoops. Okay, so benefit cost analysis. So before I get into this, I want to provide an acknowledgement that much of what we have here comes from a certification training course associated with the National Efficiency Screening Project, which developed a guidance document called the National Standard Practice Manual for doing benefit cost analysis of DERs. So it seems fairly appropriate for this presentation here. Department of Energy and Berkeley Lab supported this, and I must either claim or apologize that I'm one of the co-authors, depending on your opinion of the NSPM, and also train on this certification course. So this NSPM, National Standard Practice Manual, seems to be becoming the primary guidance resource for benefit cost analysis, really in the US and to some degree in Canada as well. Where the first one was published in 2017. We updated that in 2020. We're actually in the process of revising it and hope to have a version at the end we'll have a new version at the end of this year. And it covers a whole range of DERs. There's some other tools that exist out there. Lisa just mentioned one, this called the MTR method, tools and resources for actually quantifying the numbers you put into these benefit cost analyses. And then there's a website that has a bunch of case studies for doing benefit cost analysis of individual DERs, mostly by utility regulators or utilities, but for a range of DERs. So it's a good resource, and it's really becoming the guidance. And I'll be talking about it and what it does and doesn't do. So let's start with really basic thing here. What is benefit cost analysis? The idea here is it's a systematic approach for assessing the cost effectiveness of investments by comparing the benefits and the cost of alternative options. So basically you have an option without the proposed investment, the baseline or reference case, that counterfactual, or on one or more options with the proposed investment. And you compare that over the lifetime of the proposed investment. It's a really, again, as compared to what kind of tool, it really is the fundamental question of BCAs is as compared to what's cost effective. And typically the way the results are presented is with a benefit cost test result. And that can be a ratio, it's the BCR, the benefit cost ratio, the ratio of benefits to cost, hopefully a number greater than 1 for your investments. But you also can present it as net present value, what is the total net benefit, whether that's a negative or positive number, positive being the benefits exceed the cost. And it's often good to present both of these and to provide context, particularly when you're doing a net present value, putting out there that the net present value of this program is $7 million in of itself doesn't mean that much unless you can compare that with other similar investments. Maybe that $7 million is a huge amount of money, for your efforts, or maybe it's a drop in the bucket. So another thing I want to do before I get into the benefit cost analysis approaches I'm going to be discussing is talking a little bit about integrated resource planning. Very quickly, I just want to let you know, I don't want you to walk away thinking this is the only way to do benefit cost analysis. IRPs, integrated resource planning, is another approach. Many of you are probably quite familiar with it. Lisa and the team at Berkeley Lab and other places do a lot of work, have a lot of publications, information about this. But basically, IRPs are optimization models, scenario analysis, and they also can compare various options in a really integrated and often very informative manner. Or I should say, always very informative manner. And basically, the benefit cost analysis tests I'll be talking about, the IRPs have some common characteristics. They both focus on the long term. They use similar inputs. But the IRPs really allow for more sophisticated analysis. And the big difference is these benefit cost analysis use fixed avoided costs, avoided utilities, electricity or natural gas cost assumptions. And what that does allow for typically is more granular analysis of individual DER programs, program designs, technologies. But we're going to be talking about benefit cost analysis tests. And the starting point for those is that they reflect a perspective. They really look at the benefits and costs from different points of view. And those could be from the point of view of the program participant, the energy participant. It might be the point of view of the utility, the investor, the contractor, the manufacturer. It could be the whole society or some segment of society. Or they could be what we call the regulator's perspective. So the regulator perspective is really the perspective of those that oversee the resource investment choices. Regulator is kind of an interesting choice of word. As we were putting together these NSPMs, the co-authors, there's several of us, had a lot of debate about what term to use here. And we settled on regulator. It's maybe not the perfect term, but for us, what it's really referring to is any entity that oversees and guides these DER analyses. That might be governors, legislatures, tribes, utility boards, regional grid operators, our friends at the federal government. So the regulator in this context is really seen as a very broad term, those providing the oversight. And we'll be seeing from her a little bit later about what her roles are in this. So the BCA test for the regulatory perspective, in the NSPM, we set forth some principles and guidance on how to build your own benefit cost analysis test or modifying one of your existing tests, and one that's right for your perspective, your state's objectives, your priorities, what's been defined by your policies as what are the priorities and objectives in your jurisdiction. And so you have this jurisdiction specific test that you come up with, and it answers the question, will the cost of meeting my utility system needs while achieving any other objectives that I have in my jurisdiction be reduced by implementing these DERs? The JST might also include some secondary tests to help you. We'll talk a little bit about that. And then investments themselves are not always decided just by benefit cost analysis. There can be other analyses that complement that benefit cost analysis that are really the basis for decisions about investments. So you have in the big circle here benefit cost analysis, but within utility systems, folks often, decision makers, regulators often look at rate and bill impacts. Are the rates going to go up for all consumers, participants? The distributional analysis, how are these impacts going to be felt by different groups? By rural versus urban customers, by underserved customers versus other utility customers. And then a lot of jurisdictions, a lot of folks will be looking at economic development. How do these investments affect the jobs within my area? These are all the type of things, along with benefit cost analysis, that help determine decisions on investments. Excuse me. Well, and one more thing before we get on to building that jurisdiction-specific test. There are what we call the traditional cost effectiveness tests. Many of you might have heard of, particularly around energy efficiency programs. These were developed in the late 1990s, last updated 2001, often associated with the California Standard Practice Manual. There's a utility cost test, UCT, looks at the perspective from the utility, total resource cost test, utility perspective plus consumers, societal, looking at the societal cost test, looking at society as a whole, participant, what do consumers, participants in the program, and then the RIM test, rate impact measure test, looking at how this affect rates paid by all consumers. But what we're going to be talking about is a jurisdiction specific test. Might end up being one of these, but it's the one that you develop in order to be applicable to your jurisdiction. So what we do with these is that we start with the fundamental principles that the NSPM came up with. There's 8 of them, maybe it's 10. We'll find out by the end of the next slide. Basically saying that these things here to compare DERs with other resources, treat them consistently. You want to align your cost effectiveness with whatever the objectives are in your jurisdiction as defined by your policies. Ensuring symmetry between the cost and benefits. If you include a cost, you want to include a associated benefit and vice versa. Very important here, you want to include all the relevant material impacts. You want to be looking forward. This is not a backward looking analysis. You want to look forward. Sunk cost, you're looking forward. You want to certainly avoid double counting, ensuring transparency. And then this 8th one here, and there are 8, not 10, you want to conduct benefit cost analysis separate from the rate impact analysis. And as we're writing up this 2025 version, as I mentioned, we're looking at just really replacing that last one there with more talking about the concept that there's a lot of things that go into decisions and there can be complementary analysis like the economic development as well as the rate impact. So going forward, as you develop the JST, I just want to be really clear that this NSPM, the process I'm talking about, does not recommend any specific test. What it's recommending is a process, practices that allow you to align your goals and your objectives with the benefit cost analysis test that you use. So the principles are applied, and in a way, there might be a different test for different jurisdictions. And so you have that primary test that again answers what resources have benefits that exceed cost, and therefore merit potential support. Now, secondary tests you might apply that might help provide additional information around that primary test. So this framework that we have for this process consists of starting with these 2 phases where you apply these BCA principles, use a multi-step process I'm going to go over next to develop your primary test, what impacts to include, what costs, what benefits, to identify any other parameters that you need to use to run your test, such as discount rates, perhaps develop secondary tests, and then identify your methodologies in phase 2 for how you're going to estimate the values, the monetary values, hopefully, for those impacts that you've decided belong in the primary and secondary test. And then you're going to, as needed, have any complementary analysis, such as the rate and bill impacts, and then go into this phase 3, which is actually conducting the analysis using the test that you developed, perhaps any complementary analysis, and then that kind of brownish circle in the middle, semicircle, in the middle, make decisions on your resource investments. So there's a whole process here, a framework that's laid out in the NSPM that you can follow to develop your test. So this process, these multi-steps, is, first you want to take a look at what are your applicable goals and objectives. They're related to DERs. Take a look at those. You're going to be including all your utility system impacts because this is a test associated with investments around the utility systems, electricity or natural gas systems, for example. But you also want to include some non-utility system impacts, and those are determined based on what your goals are and objectives outside of just the utility system. And they might be environmental goals, they might be economic development goals, etc. And you want to determine basically what host customer impacts, low income impacts, for example, other fuel and water impacts. You might have a goal of conserving water. So you might want to have something associated with the water impacts associated with the DER, or other broader societal impacts. If they're important in your jurisdiction, if they're part of your goals and objectives, then you probably want to include them in your benefit cost analysis, determine what investments make sense. You want to come up with monetary values for those. The step 4 is making sure, in line with these NSPM principles, that your benefits and costs are treated symmetrically. If you include the benefit, you include the cost associated with it, vice versa. All your relevant material impacts are included, even if they're hard to quantify. If you don't include them, you're essentially assuming there's zero value. And so you want to find some way to include them if they're relevant and material. And of course, ensuring not double counted. And then step 5, transparently document this. So that's the way you're going to be, the process is putting together. Some other sort of considerations for your benefit cost analysis test are doing sensitivity analysis, updating tests, geographic boundaries. The list I have here, I'm going to talk a little bit about the first 3, and then I have a couple slides to cover the last 3 here. So sensitivity analysis, kind of an obvious thing. You're predicting what's going to be happening. There's unknowns. Always good to do sensitivity analysis. You do want to update your test and your impact values over time. You might be designing the program in 2025, but things are going to change. You want to have processes in place that allows you to put in the new values as you're implementing the program and seeing what's going on. One of the factors in determining the value of your impacts that you're including in your benefit cost test is what geographic boundary you're considering. Are you just looking at your utility system district? Are you looking at your state, your region, the country, the world? Those can all have factors in determining the impacts, say particularly around environmental impacts. Now let me turn quickly to the secondary tests. So secondary tests, as I mentioned, are something that can support your primary BCA tests, your sort of go-to reference. This is a starting point for talking about cost effectiveness. So you can have secondary tests that might be maybe one of those traditional tests that I mentioned before, maybe just your simple utility cost test or your participant test. But those secondary tests, if you put them together, they can help inform decisions. So for example, if your primary test, is really close, it's 0.95 or it's 1.05 benefit cost ratio under your jurisdiction specific test, your primary test, why don't you take a look at some secondary tests? Maybe those will indicate, whether, test really isn't worth, investment really isn't worth it, or, is worth it even if it's questionable under the primary test. The secondary test can also help with determining how much to invest, because the benefit cost analysis test indicates to you whether you should invest. Doesn't necessarily tell you how much, but secondary tests can help with that. Discount rates. One of my favorite topics, one of these things that's often not really thought much about, sort of left to the end, but discount rates can have a huge impact on determining the net present value of your cost and benefits. Basically, high discount rates tend to mean that you're focused on short-term results because they really depreciate long-term benefits and impacts and costs. Whereas lower discount rates tend to value higher future benefits and costs. So we typically think of low discount rates as more a societal perspective, maybe a multi-generational perspective. And depending on what the objectives are associated with your program, what policies are driving your investment decisions can determine what your discount rate should be. And they can have a huge influence, as this chart shows, on what the net present value are of cost and benefits. The NSPM has quite a bit of text and discussion about the different options and what they're, the ways you can look at making a selection. BCA assessment levels, another factor that will come up. Does every measure, if you're looking at 10-watt LEDs, 12-watt LEDs, 6-watt LEDs, does every measure, if you're looking at a range of measures, for residences, heating, cooling, lighting, water heating, does every project have to be cost effective, or just the program, or maybe just at the sector, or maybe just at the whole portfolio? And these are just decisions. There's pros and cons to each to decide, but it's one of the decisions you're going to have to make as to where you're applying your benefit cost analysis, your screening levels. Now, you probably, or perhaps been wondering, I've been talking a lot about all these different impacts. What are some of them? I'm going to not necessarily go through all these because that would take quite a while, and our training course takes 2 days. But in these slides here, I've got some examples of utility system impacts that might be included, and whether they're cost or benefits, whether they're applicable to different types of DERs, efficiency, demand response, generation, storage, electrification. And again, the NSPM has a great deal of information about these different impacts. Really can be a starting point for deciding which ones you want to have for your utility system impacts, for your host customer, and your society, as these ones show here. So I'll leave this one with you as we keep moving here. We're getting towards the end, and I definitely want to do our example. But just things to think about is which impacts you want to be including and what they're important. And again, they're driven by your objectives. Determining the values for those is going to be an important part. As I mentioned, that's your sort of phase 2 effort here. And fortunately, the NSPM has the methods, tools, and resources guidance for that. But the magnitude of those impacts can vary significantly across DERs and applications, and factors such as the technologies, of course, but also even who controls it, what time and location you're addressing have an impact on the value of those. Some approaches for developing those values. Well, one, of course, you can do your own, specific studies looking at, and doing analysis of what the, savings are or the impacts, environmental impacts, utility system impacts are associated within your particular jurisdiction. A lot of those do exist so you can use studies from other jurisdictions out there. If you're having difficulty coming up with values, you could use a proxy. Basically, these are values that are estimates to sort of a placeholder in some cases until you come up with some specific values. Because again, if it's relevant and material, that impact, if you say it just is too hard to come up with a number, you're essentially assuming it's worth zero. It's either a zero cost or a zero benefit. It's better if it's relevant and it's material to at least come up with some sort of estimate. Another way to deal with that unknown is to come up with alternative thresholds. There might be programs that you decide don't need to be at least a 1.0 benefit cost ratio. A number of jurisdictions say we'll use a 0.9 benefit cost ratio for low income programs because they have other objectives within their jurisdiction, within their state that these programs are going to meet. And then lastly, you could always look at other considerations. You might want to say, here's the benefit cost ratio for this, but here's some qualitative information that might help the decision maker because of the imperfections of the unknowns that might be associated with your benefit cost test. So with that, let me just sort of say a summary of this benefit cost analysis. It's a systematic approach. Key here is systematic. For you to come up with your own test that's applicable for your own objectives, for your own goals, for your own policies are applicable within whatever area that you're going to be doing this program. It's not necessarily the only basis. Remember, there's complementary analysis to be done. It's important to understand that it reflects a perspective. It's going to be that perspective of the utility, the consumer, the jurisdiction, of your regulator, whoever that regulator might be. You always want to include the utility system impacts, obviously things transmission, distribution, cost and benefits, but also perhaps around resilience and reliability, risk reduction, because these are utility system resources. But you can also include other impacts from the participant or society. You want to, again, account for all those relevant and material impacts. That NSPM sets forth some principles. It's a pretty good resource. And there's among the many others that can support you in those efforts. So with that, I'm going to conclude that portion. Let's see, Lisa, if there's any questions. And while we're doing that, I'm going to start bringing up the example.
I don't see any questions in the chat. Folks can raise their hands or put a question in the chat at this time.
Okay, let's find the right one for that one. Oops, sorry. I'm sorry. I have too many screens open. It's here. I know it's here. There it is. All right. Well, I'm surprised it's on the last slide again. All right, let's go. We got about 15 minutes and we're gonna go through an example. Okay, so this example we put together is about managed charging of electric vehicles. Thought that might be interesting for folks, maybe a little more exciting than LED light bulbs. And we try to do in this one is provide a little bit of background and pull together some of the items discussed in the program planning and evaluation, as well as the benefit cost analysis. So first, I just quickly go over what's managed charging for electric vehicles, and then go through a little process for coming up with a benefit cost analysis to support your program planning evaluation. So background, managed EV charging. So the idea here is with electric vehicles is you might be interested in having a program that instead of just having consumers charge their vehicles whenever they can or want or feel like it, you want to optimize that to support the grid effectiveness, efficiency by reducing peak demand or responding to local or system-wide grid conditions. So you might provide incentives or various pricing mechanisms. So the idea here is that the total energy consumption is the same. They're going to be charging their vehicles, but by managing it, you're changing the timing. So you can lower the energy costs for the consumers by getting them to charge during, off-peak times, during cheaper energy rates. This might be able to avoid capacity upgrades if there's a lot of chargers on a particular substation, for example, or for the transmission system in general. And basically, it might also be able to take advantage of lower cost resources for everybody, for the grid operator as well as for the consumers. So these two little charts here show you the idea, just everybody's charging, during a certain period of time versus a more spread out charging to levelize the capacity requirements of the system. Types of programs you might see, can categorize them as active programs or passive programs or just rates. So an active program might be something where it's event-based. We basically have controls in place that limit the number of charging that can be done at any given time. Whereas a passive program might be something where it's just really a behavioral program, say just encouraging off-peak charging, and then energy rates. And the most common again is having some sort of peak demand charges, or for example, in the service territory that I am, there's EV only rates that are available with separate meters. So there's a range of program types that can be used for that. What we're going to talk about is coming up with benefit cost analysis for a program. So the steps to do that, I've sort of compressed in here the various steps I talked about program evaluation and benefit cost analysis here into this sort of one diagram. And so the first thing I do is identify the set of alternatives. What are the managed charging options that you're going to look at? And identify the primary cost effectiveness test and perhaps any secondary test you're going to be using. In identifying those tests, you're going to determine which utility system, host customer, and potentially societal cost and benefits to include in that analysis. For these, you're going to want to forecast program and rate enrollment levels because that's going to be really critical to determine the magnitude of your impacts. Are 10 people going to sign up or 100,000 people going to sign up? You're going to come up with values for those impacts that you've included in your test. That's the 1, 2, 3, 4, fifth box. Monetize those because our benefit cost analysis test, involves dollars and cents, not kilowatt hours or number of participants. Hopefully conduct some sensitivity analysis, and then let's present our results and see whether these programs look effective or not. So identifying the set of alternatives, I'll specify those combination of programs and those active programs, passive programs, rate structures that you're going to be looking at. Identify them as separate alternatives so you don't have double counting. You can certainly do combinations, but that combination would be a separate alternative in itself. And then you want at least one status quo, that baseline, that counterfactual that you're going to be using at least as a baseline for comparing your different options with. And then your timeline of analysis, what's your time period that you're thinking about for, is this something where it's got to be cost effective within 3 years, 5 years, or, are you looking longer term, to 10, 20 years out that determines the period of analysis. And then certainly, the design features that you can have, would really get more to the benefit cost, more to the managed charging program design. But, these are types of alternatives with sectors, with vehicles, is it people's, residential, homeowner, recreational vehicles or school buses, using rates or using incentives, et cetera. So identifying the primary cost of this test, well, just in the prior presentation, I went through a process where you develop a jurisdiction-specific test, but it's possible in your area that you already have an established test that's required. You might want to, modify it, but that's going to be a determination you're going to have to, whether through the JST process or by just using one that's established, you need to determine which test is used and whether you can use any secondary test. So now turning to which cost and benefits to include, again, the categories in general are the utility system, the host customer, or the societal cost and benefits. And these graphics here, I'll read some of the line items. I realize it's pretty small. This is from a forthcoming Berkeley Lab report that looked at the types of cost and benefits that were included in many of these managed charging benefit cost analyses that have been done around the country. So benefits, most common ones, somewhat obviously, would be distribution, generation capacity, transmission capacity, and the amount of energy generation. But other benefits, such as greenhouse gas emissions, improvements in reliability, bill savings. And then cost, of course, is the program administration, any financial incentives. The host portion, the consumer, so they have to put in specialized charging equipment. Again, is that going to be the cost of that charging equipment, or is it the incremental cost to be able to participate in your managed charging program because that requires specialized equipment? And again, that's looking at your baseline versus your project case. So again, determining the utility system, host customer, and societal cost benefits to include. Then the enrollment levels, estimating what the adoption is of EVs in general, and then the adoption and participation in your program itself. And, obviously this can vary over time. Got a couple of examples here of data showing the adoption rates of EVs themselves. And if they have EVs, they're charging them somewhere. On the data sources for that can be, again, pilot programs, similar programs, or, looking at surveys that are done of potential participants, and then the old Delphi panels, which is basically gathering a group of experts together with familiarity and asking their opinions to get your program and rate enrollment levels. One of the things that can affect this as well as to whether you have opt-in or opt-out type designs where people have the option of opting in or everybody's in and they have to opt out if they don't want to participate. So now you got to come up with monetary values for this. This is typically going to be associated, with your utility rates. So you have a, KWH, KW impacts, primarily moving KW from one time period to another. And hopefully you're going to have some interval data that's available that demonstrates, how these programs have an impact based on prior programs from prior years, or maybe from your randomized control trial, your control study. But if you don't, you're going to perhaps have available data from other studies, other sources. There are load profiles available that vendors have as they're selling charging equipment, but also there's some publicly available resources such as from our sister national laboratory, National Renewable Energy Laboratory. Again, the links are here when you have these slides. I mentioned before, I like sensitivity analysis. We're predicting the future. And so there's certainly going to be uncertainty. And so, exploring some of the uncertainties, and here's an example analysis. Again, I realize these are rather small, but, trying to, show the range of impacts based on, various changes and how many people are opting in or out, the participation charging times, when they actually do charge or not based on experience. Or just try to do sensitivities, et cetera, et cetera. Even do a sensitivity on discount rates. I was talking before about the importance of discount rates. So you can use that as one of your sensitivities. again, to present to the decision makers, information that shows really a range of what the benefits and costs can be versus saying this is absolutely going to be a 1.076, benefit cost ratio. Presenting the results, again, just examples here of ways you can present the results, and just want to be transparent and explain the methodology, documenting the assumptions, giving some indication of what the certainty is associated with the numbers here, because that affects the decision makers. And they're going to realize there's some uncertainty, and as more specific you can be about that, gives more confidence in the results that you're presenting. And then if you need to, there's some non-monetized impacts, there's some other issues that you think are important, you certainly can provide that in qualitative summaries as well as presenting numbers, showing, in this case here in this graphic showing, the red on the left, all the program costs, and then the far right, all the program benefits, and then the components of that in between in this one graphic way to show it. So some considerations, also as you're putting together the program itself is what are your evaluation needs going to be, and your ongoing benefit cost analysis, looking at what information is going to be needed to do your long-term benefit cost analysis. And that benefit cost analysis is going to be based on, what the impacts are, the timing of those impacts, and how many people participate, and what the energy costs are, both to the consumer and to the system during the times of charging or not charging for not only the actual program, but for that counterfactual baseline. So gathering up that data, planning for that, knowing what you're going to need, budgeting for it up front is going to be important so that not only do you have the estimated before the program's implemented benefit cost analysis results, but you also have benefit cost analysis, after the program, and ideally even during the program, and using that information to make modifications as needed to the program design to improve that benefit cost analysis, benefit cost ratio. So with that was kind of a whirlwind flow through here. By my clock, we have a good 3 minutes left to see if there's any comments or questions.
Thanks, Steve. That was great. I put a link in the chat to a place where we'll be posting our report on this topic, best practices for benefit cost analysis for managed charging programs and rates, hopefully by the end of the year. Does anybody have a question that they would like to ask? You can just take yourself on mute and ask the question at this point, or put a link in the chat, or put a comment in the chat.
Well, it was all perfectly clear. No,
It was totally clear, and
all totally clear. Go out and I'll do all of it now. I think
and
what we're trying to do is get you enough, at least enough information to ask good questions.
I put Steve's email address in the chat in case anybody wants to reach out to him about tools and that kind of thing. So we have, Marty, you're gonna come back and do a skills session, right, shortly?
Yes, that's correct.
All right.
Well, maybe we should give everybody 1.5 more minutes of their lives back. Well, thank you, everybody. I want to, certainly, Marty, thank you and the Department of Energy for the opportunity to talk with these so impressive fellows. And hopefully it was useful for you. And please go out and do good things.